So I was talking about yes, bitwise operators, right? So in bitwise operators, always it will perform the operation by converting into zeros and ones. So there is a left shift operator and there is what right shift operator. Now left shift operator is for shifting number of bits towards the left side, and right shift operator shifting number of bits towards the right side. Now there is other bitwise operators. Now you have other bitwise operators like what is that other operators is this is called as bitwise AND operator. So actually these are the operators which are used for applying the logical gates. Like in computer science or in electronics, you find some logical gates or logic gates like AND gate, OR gate, NOT gate, NAND gate, exclusive OR gate, NOR gate, like that. So this bitwise operators are used for applying which one your logical gates. So what is that logic gate is? So what is the now what the logic gate is? I think this is a definition of logic gate. Logic gate. Logic gates are basic building blocks of any digital system. It is nothing but it is an electronic circuit having one or more than one input and one output. See, logic gates are the building blocks of any digital system, and it is an electronic circuit having one or more than one input and only one output. Okay, one or more than one input and only one output. A logic gate is a device that acts as a building block for digital circuit. They perform basic logical functions that are fundamental to digital circuit. Most electronic device we use today will have some form of logic gates in them. Like there are some different types of logic gates you can find. If you see these are logic gates, you find different logic gates here. Okay, you find different types of logic gates. Now, if you see this logic gates, I can see this is the symbols are AND gate. Okay, and this is called as OR gate, and this is exclusive OR gate, and this is NAND gate, NOR gate, and exclusive NOR gate. So this is useful when you're working with embedded applications. Okay, so this is useful when you're working with embedded applications where you can control the digital systems electronic device by sending bits from this logical gates, right? So here there is a AND gate you have. Yes. So bitwise AND operator. So generally bitwise AND operator, you can use it for applying which gate here AND gate. So bitwise AND operator is there. Okay, now this is a simple definition of logic gates. So here I'm writing what is logic gates here. What is logic? What is logic gates here? What is logic gate? So logic gates are basic building blocks of any digital system like this. So yes, this is how it is. Now here, this bitwise operators. If you see these bitwise operators, You can use this bitwise operators to apply this logic gates. So this operator is used to apply what is that bitwise to apply AND gate. You can use this for applying AND gate. Now if you see the truth table of AND gate, so what is the symbol we are using? Ampersand. Ampersand is a symbol. And to apply this AND gate, now this is a truth table. So there is operand 1, operand 2, and operand 1. And what is that? Operand 2. So there is operand 1, operand 2, and there is operand 1 and so 1 0 is 0, and 0 1 is 0, and 1 1 is 1, and 0 0 is 0. If any input bit is 0, the output bit is what? 0. Okay. If any one input bit is 0, if any one input bit is if any one or input bit, if any one or if one input bit is 0, input bit is 0, the output bit is again, the output bit is what again? 0. So here 1 0 is 0, and 0 1 is what again? 0, and 1 1 is a 1, and 0 0 is what again? 0. If one input bit is 0, the output bit is what again? 0. If any one input bit is 0, the output bit becomes 0. Okay. So that is what will happen if you are working with this. So that is what will happen when you are working with this. But how these operations are done? So it will try to do these operations by converting into bits. So but I am saying now this is useful when you are working with the embedded systems. Now A equal to 15 and B equal to 12 and C equal to A and B. If I am writing C equal to A and B, so first these two values you have to convert into word binary, because these are bitwise operators and you have to apply. By converting these values into what is a binary, so 2 7 and 2 3, and the remainder is what again? 1, and 2 1, and the remainder is what here? 1. So what is the equivalent of value? 0 0? Okay, 0 0. You have to represent always in 1 byte format. So 1 byte is nothing but 8 bits. So after that 12, you have to convert this into what is this here? Binary. How many times here? 6, and remainder is 0. How many times here? 3 times, and remainder is 0. How many times here? 1 time, and remainder is 1. So what is the value of this here? 0 0 0 and double 1 double 0. Now you apply the truth table. 1 0 is 0. 1 0 is again 0. 1 1 is a 1, and 1 1 is a 1. And remaining all are what here? Zeros. So what is my value here? Double 1 double 0. So convert this into a binary decimal. 2 to the power of 1 into 0 plus 2 to the power of 2 into 1 plus 2 to the power of 3 into 1. So what is the value of this? Now this is 2 to the power of 3 means 8 plus. Okay, 8 plus 4 plus. Okay, 0 plus and 0. And what is the equivalent value here? 1. But you have to do this operation by converting into what? Bits. That is nothing but in you have to convert in zeros and ones. You have to convert the values into zeros and ones, right? So whenever, yeah, generally it is used to apply this particular gate. This is called as which gate here? AND gate. To apply which gate here? AND gate. So for that, yeah, it is used. I said no, it is used in embedded applications. But just try to understand how internally this logical gates, how internally this logical gates works. The value of A is given 15, the value of B is 12, and the C equal to A and B, and print A value, B value, and C value. I can see 15, 12, 12, and there is a binary of A. I try to print in binary format. So for that, I'm using a function called bin. So binary of A, and this is a binary of sorry. So print binary of A, binary of B, and binary of C. Now this is a binary of A, and this is a binary of B, and this is a binary of C. Okay, this is how the AND gate works. This is how AND gate works here. Okay, this is binary or bitwise AND operation. So where you are trying to print all the values in which format? Binary format. So this is AND gate, and there is a bitwise. Bitwise pipe symbol is there. Bitwise pipe symbol is OR gate. Okay, now this is called as OR gate. Bitwise and OR operator. Bitwise OR operator. So this operator is used, okay, to apply, logic, bitwise logic. I mean OR gate. This is for applying which gate? OR gate. And you are applying this OR gate. Now this is a truth table. Now if you see the truth table of this, how it is, it is like this. There is operand 1, and there is operand 2, and there is operand 1 or operand 2. Or, so or operator is what? Pipe. So 1 0 is 1, and 0 1 is 1, 0 0 is 0, 1 1 is 1. Now just here, this is how it is. So if any one input bit is, if one input bit is 1, the output becomes what? 1. If one input bit is 1, so the output bit is 1. The output bit is what here? 1. So in this case, 1 means on and 0 means what here? Off. 1 means on and 0 means what here? Off. So this is what is the meaning of logic gate. Logic gates are the basic building blocks of any digital system. It is an electronic circuit having one or more than one input, and only how many outputs are there? Only one output. Yes, if any one input bit is 1, the output bit is what? 1. So again, if you see the example of this, so I've taken the value of A is, the value of A is some, assume that 10, and the value of B is, okay, assume that some 13, right? So there is a value 10. So how many times here? 5 times. And remainder is what here? 0. How many times here? 2 times. And remainder is what here? 1. How many times here? 1 time. And remainder is a 1. So what is a 10 equivalent of binary? 1 0 1 0. Then you need to convert this 13 into binary. So how many times here? 6 times, and remainder is a 1. So how many times here? 3 times. And remainder is what here? 0. How many times here? 1 time. Remainder is a 1. So here I've taken 1, 1, 1, 1, 1 what? 0, 1. So apply the truth table now. 0, 1 is 1, 1, 1, 0 is 1, 0 is 1 is 1, 1, 1 is again 1. Now convert this into decimal. 2 to the power of 0 into 1, 2 to the power of 1 into 1, 2 to the power of 2 into 1, and 2 to the power of 3 into 1. Now this is nothing but 8 plus 4 plus 2 plus 1. Okay. Now this value is what now? 15. So 15 is which value here? Decimal value. So you have to convert. Okay. Before doing operation, you have to convert this values into what? Binary. You have to convert these values into what here?
Okay.
Binary. So there is a 10 and there is a 13 and 5 and 0, 2 and 1 and 1 and 0 like this. Now that is how you are converting. This operator is used to apply OR gate. Now this is a truth table of it. Let us see A value is 10. Let us see A value is 10 and B value is what here? 13. C equal to A or B. C equal to A or B. A value, B value and C value. And you can print binary of A and binary of B and binary of which one? C. Okay, now these are binary representation of all these values. So binary representation of all these values here. Now this is the output of it. But I'm saying now this is useful when you're working with embedded applications. Otherwise, you don't use this AND operators and what? Bitwise and OR operators. So there is one more operator called XOR operator. XOR operator or exclusive. This is called exclusive OR operator. Okay, now this operator is used to apply what is that XOR gate. If you see the truth table, see all these are truth tables of it. Now if you see this is a truth table of, now these are symbols. If you see the symbols, now these are the symbols. Now you can see all these are symbols: AND gate, OR gate, NOT gate, and this is what here exclusive OR gate. Okay, now NOT gate, AND gate. Okay, see here 0 0 is 0, 0 1 is 0, 1 0 is what? 0 and 1 1 is 1. OR is 0 0 is 0, 0 1 is 1, and 1 0 is 1, 1 1 is a 1. So like that, there is an exclusive OR operator. Now 0 0 is 0, and 0 1 is 1, and 1 0 is 1, and 1 1 is what? 0. So if you see the truth table of this exclusive OR gate, XOR gate, so it is like this. So what we are trying to do is operand 1, and there is an operand 2, and there is an operand 1, exclusive OR. Exclusive OR and operand 2. So here 0 0 is 0, and 1 1 is 0, 1 0. Okay, 1 0 is 1, and 0 1 is a 0. So in this case, if any one input bit is 1, the output bit is what here? 1. If any input bit is 1, output bit is 1. But if both the bits are equal, the output is what? 0. Okay. If two bits are equal, output bit is what? 0. If one bit is 1, The output bit is what here? 1. Okay. So that is what will happen if you are working with exclusive or operator. So this I am telling you because of just to have a knowledge of it, like how to use this AND operation, OR operation, and one more is what? Exclusive OR operation. Exclusive OR operation. Okay, exclusive OR operation here. So, so what you can do is you can directly take the value in binary 0B101 N2. Can you give directly value in binary or not? Yes. So this is which value your binary value, and 0B, okay, 1 1, okay, 1 1 0. And I'm saying N3 equal to N1 exclusive OR. N1 exclusive OR N2. When I write here N1 exclusive OR N2, so here 1 0 is what? 1, and 0 1 is a 1, and 1 1 is a 0. So 1 1 is nothing but 1 1 is nothing but 3. Okay. So I try to print the value of N1, N2, and N3. So 5, 6, and one more value is 3. So I try to print N1 value, N2 value, as well as which value? N3 value. Now you can see 0B101 and 0B110 and 0B, what is that? 1 1. This is applying which operation here? Exclusive OR operation. Exclusive OR operation. Okay. And there is one more operator is there. So that is bitwise not operator. Bitwise not operator. Okay. Now if you see the truth table, if you see the truth table of bitwise, what is this? Not operator. Not operator is. So it is opposite, right? It is opposite of it. So there is a operand 1 and there is a not operand 1. If operand 1 is 1, not operand 1 is 0. Operand 1 is 0 and then not operand 1 becomes what? 1, right? So here you can apply simply one formula. The formula what you can apply to get the result is, okay, so minus of, okay, operand 1 plus 1. Minus of operand 1 plus 1, operand 1 plus 1. So what is the meaning of this is, for example, the value of A is 5. The value of A is 5 and the value of B is and A. So when I'm saying and A, the value of A and B is, the value of A is 5 and the value of B is what? Minus 6. So just apply this formula. Otherwise, you have to convert. You have to take binary equivalent of 5 and you have to take 2's complements and then you have to add 1. It's a lengthy process, right? So you can apply simply one formula minus operand plus 1. Suppose I take the value of B equal to some minus 7, then C equal to not B. And if I'm trying to print B and C values, and B value is minus 7 and C value is what? 6. Okay, because minus of minus becomes what? Plus. Minus of minus becomes what here? Plus. Okay, minus of minus becomes a plus. These are applying which gates here? Logical gates. So there is a AND gate and there is a OR gate and there is what? Exclusive OR gate and there is which one? NOT gate. Okay, fine. Next we'll see. So there is a, okay, there is other operators like, what is that? It should be minus operand minus 1. Why? Why should be minus operand minus 1? -5 minus 1 is -6. Then I should write like this, right? Okay. Okay, now. So there is an identity operator. There is an identity. You have to understand here. I should not say that. Uh, Grouping I should write here. You should understand this one, right? Okay. So there is an identity. There is an identity operator. Identity operators. Identity. Now this is very much useful. Like what is a identity operator here is every object in Python is having identity. Every object in Python is having what? Identity. Every object in Python is having an identity. Okay. So every object in Python, every object in Python is having identity, and this identity is called which one? Address. This identity is called as which one? Address. So Python provides okay identity operators to compare which one? Addresses. Identity operators are used to compare which one? Address. Okay. So there is only one operator called is, but you can also use this is with what here? Not. Is not. Is and is not. Okay. Is a keyword and not is also keyword. Now, where this is useful is if you want to know it whether two variables are holding the same identity or different identity. If you want to know it whether two objects are pointing to the same, I mean, two variables are pointing to the same object or different object. Two are pointing to the same objects or different objects. For example, so this is a binary operator. Okay, this is binary operator. This is binary operator. It required how many operands here? Two operands. Okay, and this operator returns boolean value after comparison or after comparing. What it returns here? Boolean value. If it is a true is written if both are pointing to the same object. Otherwise, it will return what? False. So in application development, these are used to compare what? Addresses. So what is the meaning of this is, for example, the value of A is some 20. Okay, the value of B is again 20. Because integers are immutable, they are shareable or not? Yes. So is it address of A and B both are same or different? Same. Means A and B both are pointing to the same object or different object? Same object. If I'm writing A is B, what it returns? True. If I'm writing A is B, it is written what? True. Because is it A and B both are pointing to the same object or different object? Same object. A and B both are pointing to the same object. Address of A and address of B both are what here? Same. Because integer is immutable. Because integer is immutable, they are what? Shareable. For example, we'll take another one, like suppose list. I'll take one list. So L1 equal to 10, 20, 30. This is one list. This is one list. List is list is mutable. If it is mutable, it is not shareable, right? Now again, I'm saying 10, 20, 30. Is it these are two different objects or one object? Different objects. If you want, you can see ID of list one, and this is the ID of list one, and this is the ID of which one? List 2. Oh, sorry. Is it ID of list 1 and list 2 both are same or different? Different. If I'm saying L1 is L2, is it written true or false? False. So is used for comparing which one? Addresses. Is used for comparing which one? Addresses. For example, I try to copy this address into another variable. Now L1 address is assigned to which one here? L3. If I'm saying L1 is L3, L1 address is assigned to which one here? L3. If I'm saying L1 is L3, is it both are holding the same address or different address? Same address. Now in this case, it is written what? True. If I'm saying L1 is L3, what is the value it is written? True. Because L1 and L3 both are holding, L1 and L3 both are holding same address or different address? Same address. So it is written value called which one? True.
Great.
Okay, so just try to understand. Is operator is used for comparing what? Addresses. Is operator is used for comparing addresses. Addresses. But for comparing values, you will try to use double equal operator. If you want to compare values, you'll use which operator? Double equal operator. I'm writing A equal to 10 and B equal to what? 10. So there is a variable A, there is a variable A, and A is holding, A is holding an object whose value is 10 and whose ID is what here? 1000. So your ID is nothing but which one? Address. Now here A is holding the address of which one? 10. And when I say B equal to 10, now there is a object with the value 10 is already exist or not? Yes. So will it create a new object or assign the same object? Same object. It will not create a new object because integers are immutables. Because of immutables, they are what? Shareable. Is it A and B both are pointing to the same object or different object? Same object. Means is it holding same address or different address? Same address. If I'm saying A is B, A and B both are holding same address or not? Yes. Then it returns what here? True. Suppose I've taken list. I've taken list by saying 10, 20 and 30. Then what will happen? It will create one list. Okay, it will create one list and this list is having how many values? Three values, 10, 20 and 30. Okay, assume that address of this particular object is 2000. This is a variable L1. L1 is holding the address of list and having how many values in that? Three values. Because list is a mutable, they are not shareable. List is a mutable, they are what? Not shareable, even though having same values. L2 equal to 10, 20, 30. Then what will happen? Will it assign the same address or different address? Different address because it will create one new object. Now this is one more list. Assume that address of this particular list is 3000 and this is having how many values? Three values, 10, 20, 30. This is a list 2 and the list 2 is having list 2 is having what here? 3000. Okay, list 2 is having what here? 3000. In this case, if I'm writing, if I'm writing L1 is L2, L1 is L2 now. Is it L1 and L2 both are pointing to the same address or different address? Different address. Is it address are equal or not equal? Not equal, then it returns what here? False. Suppose if I'm writing A double equal to B, A double equal to B means, is it comparing addresses or values? Values. Okay, double equal is for comparing which one? Value. Double equal is for comparing value and is for comparing, is for comparing which one? Address. Is for comparing address and double equal is for comparing values. So is it A and B both are having same value or different value? Same value. What it returns here? True. What it returns here? True. If I'm saying L1 double equal to L2, If I'm saying L1 double equal to L2, what it is comparing? Is it comparing addresses or values? Values. Now, is it 10 is equal to 10? Yes. Is it 20 is equal to 20? Yes. Is it 30 is equal to 30? Yes. Now, double equal is comparing values or addresses? Values. Now, in this case, it is written what here? True. So double equal operator is for comparing the state of the object, and is operator is for comparing which one? Address. Double equal operator is for comparing the state of the object, and is operator is for comparing which one? Address. Now what is the difference? Sometimes I may ask you, what is the difference between is operator and double equal operator? Now is operator is used for comparing address of objects, and double equal operator is for comparing the state of the object. State is nothing but what? Values. Now in application development, this is used to identify, in application development, this is used to identify, is it one variable hold the copy of any other object or not. I want to know, is it this variable, is it this variable is a copy of the existing object or not. I create a copy, I want to check. I create a copy of the object, I want to check, is it copies created or not. How can I find out is it copies created or not? I have to compare what? IDs. But how can you compare IDs by using which one? Is operator. How can you compare IDs by using is operator? Now, is will return true if both are holding same address. Is not will return true if both are not holding same address. Is not will return true if both are not holding same address. Okay, not holding same address. Okay, suppose if I'm saying L1 is not L3. Is it L1, L3 both are holding same address or different address? Different address. Now, is it written true or false? Is it holding same address or different address? Different address. Sorry. L1 and L2 both are holding same address or different address? Different address. Now, it returns what? True. It returns what? True. Is not means not holding same address. Okay. Suppose if I'm saying L1 is not L3, is it L1 is holding same address or different address? Same address. Then it returns what? False. Now this is opposite, right? This is which one here? Opposite of is. So, but these are used for comparing addresses, and double equal is used for comparing what? Values. So what is the difference between double equal operator and which operator is operator? What is the difference between what is the difference between what difference is between double equal and is operator? Okay. Now this is the difference between double equal and one more is what? Is. Okay. Now this operator is used. This operator is used to compare what here? State of the object. State means what here? Value. Values of object. Values of object. And this operator is used. This operator is used to compare address of which one? Objects. Okay. And both will return boolean values only. Both will return boolean values. Okay, now that is the difference between double equal operator and what is operator. So there is a double equal and there is one more called which one? Is. I think this is frequently asked question, might be. Sorry. This is frequently asked. What is the difference between is in Python? Okay. Yes. The double equal operator compares the value or equality of two objects, whereas a Python is operator checks whether two variables point to the same object in memory. So same object in memory means, is it for comparing address or not? Yes, it is for comparing address. Even this definition also I'll put here so that you can remember this. So this is what is the difference between identity operators. Okay, and there is one more operator is there. What is that operator is? Membership operator. There is one more operator is there, and what is that operator is? Membership operators. Membership operators. What is this membership operator is? Okay. So actually membership operators, membership operators are used with collections. Membership operators are used with what? Collections. Okay, and these operators are used for searching, for searching. These operators are used for searching a given value exists in a group of values, in a group of values or what? Collection. These operators are used for searching. What is this here? Searching. Searching or finding. Given value exists. Okay, given value exists in what? Group of values or collection of values. So that comparison you are doing it using which operators? Membership operators. Now there are two membership operators. One is in and one more is what? Not in. Actually, there is only one membership operator in, but you can use this in operator with another operator called which one? Not in. You can use this in operator with another operator called which one? Not in. So there are two membership operators. One is in and one more is what here? Not in. Okay, but these operators return these operators returns this operator returns which value? Boolean value. Okay, this operators returns these operators return which value here? Boolean value. These operators return which value here? Boolean value. So that will return either true. These operators return Boolean value. That value can be either true or what is a false. It returns Boolean value that can be either true or false, right? So there is an operator called in, and there is an operator called which one? Not in. Two operators are there. One is in, and one more operator is what? Not in. This is very simple. For example, this is used with the collections, but not on single values. Inside. In is what? Inside. Okay, inside. Is it this value is there? Okay, is it this particular object is there inside? Is it this particular object is there inside a group of objects? Is it this particular object is there inside? In means, is it this object is there inside all these objects? So all these are objects, right? And these are so many objects are there in my collection. And I want to know whether this object is there inside these objects. If this object is there inside this object, if it is there, it will return what? True. If it is not there, then it returns false. So I cannot say one object inside another object, right? Okay, this object should be which type here? This destination object should be of which type here? Collection type. Okay, I cannot say integer in integer. 10 in 10. If I say 10 in 10, it will give what? Error. 10 is which type? Standard type. And 10 is also which type? Standard. One value inside one value. No. One value inside a group of values. So this syntax is valid or invalid? Invalid. I can say 10 inside. Is it 10 is there inside? Okay, 10, 20, 30. Now this is called as which one? List. This is called as one list. Now is it 10 is there inside a list of values? Yes. Then what it returns here? True. If it is not there, it returns what here? False. For example, I have a list of mail IDs. I have a list of email IDs. I want to search. Is it this email IDs exist? I want to search. Is it this email IDs exist in a list of email IDs? Then I'll use which operator? In operator. But I can use in operator only on which types here? Collection types. Okay. So there is a list of phone numbers, and I want to search whether this number is exist in a list of phone numbers. I want to know whether this phone number is exist in the list of phone numbers. If the phone number is exist in list of phone numbers, I want to perform certain operations. If it is not exist, I want to perform certain operations. Is it this username? Is it this username is exist in list of usernames? If this username is exist in list of usernames, I perform certain operations. If it is not exist, I perform some other operation. So you are finding a values exist in a group of values by using which operator here? In operator. So in operator returns true if it is exist. In operator returns true if it is exist, and there is another operator called not in, and not in operator returns true if it is not exist. In operator returns true if it is exist. Not in operator returns true if it is not exist. Right? Opposite. Not true, not true. True means true. Not true means false. Okay, true means true here. True is there. True means true only. But if I'm saying not true means false. If I'm saying not false is not false is what here? True. Okay. Yes. Not in. It is not exist in. If it is not exist in a group of values, return true. If it is exist in a group of values, then returns true. So group of values means I have to take one collection, right? Group of values means I have to take one collection. I'm saying 10 inside. Is it 10 is inside a collection of values? Now I take one list. Square brackets means one list. Okay, but you learn list again. In that again you'll learn, but just try to understand this is what here listed. And this list contain how many values here? 5 values. Is it 10 is exist in these 5 values or not? Yes. Then it returns what? True. And 10 not in, 10 not in, 10, 20, 30, 40, 50. Is it 10 is not inside these 5 values? No. It is there. It returns what? False. If I'm writing 100 and not in, 100 and not in, okay, 10, 20, 30, 40, 50, 100 and not in 10, 20, 30, 40, 50, is it 100 is not there in this list of values? Yes. Then it is written what? True. I'm trying to say in, Java in list of courses. There is a course called Python. There is a course called C. There is a course called C++. There is a course called which one? Oracle. Is it Java is there in list of courses here? No. Then what it returns here? False. But if it is exist, it returns true. If it is not exist, it returns what? False. Exist. In means searching. Okay, in means nothing but here what? Searching. For example, I'm saying A in Python. Python is also, is a string is also one collection or not? Tell me, is a string is one collection or not? Yes. String is also one collection, and string is a collection of characters. String is a collection of characters. Now this string is having how many characters? 1, 2, 3, 4, 5, and 6. The string is a collection of characters, and inside the string you are searching for which one? A. Is it A is inside Python? No. Then what it returns? False. Suppose if I'm writing some O inside, is it O is there inside Python? Yes. What it returns? True. Okay. Now, if you want to search one value inside a group of values, if you want to search one value inside a group of values, then it returns true. Otherwise, it returns what? False. I want to find. For example, I want to find write a program. write a program to find input character is vowel or not. I want to find input character is vowel or not. So I have to input one character, right? I have to input one character, enter any character, enter any character. So if I want to find out is it this character is vowel or not, I have to write printer. I'm saying format. This character is what? This character. This character is what here? Vowel. When I should print this, if character double equal to what? A, or character double equal to what? E, or character double equal to what? I, like this. I have to write so many conditions or not? Yes. Instead of writing this many number of conditions, I can simply write is a character is in inside AE IOU. Is it this character is there inside this AE IOU? If it is there, it will print this character is what? Vowel. I can give uppercase. I can give uppercase as well as what? Lowercase. I can give uppercase as well as what? Lowercase. Now this makes it development more easier, right? If this in is not there, I have to check how many conditions, number of conditions. CH double equal to A, or CH double equal to what? E, or CH double equal to what? I, or CH double equal to U. Instead of writing these many things by separating with what? OR operation, I simply use which operation? In operation. Is it this character is there inside this group of characters? Is it this character is there inside this group of characters? Then it returns true. If it is a true, it will print left hand operand. Else I'm saying print is a consonant, right? I'm saying format character is not what is that? Vowel. This vowel, otherwise I'm saying this character is not a vowel, right? Now this is now once I run this, now this is my character. A is a vowel. I run this. I put capital A. Capital A is vowel. I run this. I'll enter some X. X is not a vowel because is it this values there in a group of these values? No. Now in Python, this is one of the important operator in operator. One of the important operator because this is for searching. Searching is required. For example, there is one collection with the sales. Okay, there is a sales collection is there with dictionary is there. One dictionary. So dictionary is having key and values. Key, assume that there is a sales dictionary which contain key as a year and sales as a value. I want to find, okay, I want to find the sales of some particular year. Then I'll try to say, I want to find the sales of some 2010. I'll say 2010 in what? 2010 in what? Dictionary. If 2010 is there in dictionary, it returns what? True. If it is there, I'll read the value. If it is not there, I'll say this year is not found. This year sales is not found. So this is one of the important operator in Python, and that operator is what? In operator. In, you have to remember in. So if you take classroom is one collection, now so many students are there. I want to know whether the student is inside what? Classroom. Okay, is it the student is exist inside what? Classroom. If it is exist, it returns true. Otherwise it will return false. Means you don't require to write which logic? Searching logic. You don't require to write which logic? Searching logic. Searching logic you don't require to write. So that is taken care by which operator? In operator. If you are working with a C or C++, a Java, you have to write searching logic. Searching logic. You have to take each value and compare with what? All the values. But here no, I simply use which operator? In. That's it. If it is there, it returns true. If it is not there, it returns what? False. This is an example here. Okay. Yes. Okay, right now this is how it is. So yeah. Yes. Now that is which operator here? Membership operator, like in operator, and one more is what? Not in operator. So there is one more operator is there. See, this operator is repeated. This operator is what here? Repeated. Repeated. This in operator again. You'll be learning when you go for collections. पर जब नहीं बोलने कि इन क्या है नॉट इन क्या है बोल के अब से याद रखना इसको ओके थ्रू आउट पाइथन यू हैव टू रिमेंबर दिस इन एंड व्हाट इज दैट नॉट इन okay so very simple operator but remember this operator and there is one more operator called which one walrus operator there is one operator called which one walrus operator okay walrus operator what is this operator is this is called as walrus operator it is also called assignment expression walrus operator or it is also called assignment what here expression assignment expression operator it is called as walrus operator or assignment expression operator are you getting or not okay so that is called as what is the symbol of this walrus operator is colon and equal colon and equal that you can call it as which operator walrus operator. Yes, just try to listen this. Now this is walrus operator. Okay. Yes. Colon and equal. Colon and equal is called walrus operator, and this operator is introduced. So 3.8. This the walrus operator is introduced in Python 3.8 version. Okay. This operator. So what is the operator symbol here? Colon equal. This operator is introduced. This operator is introduced in which version of Python? Python 3.8 version. This operator is introduced in Python 3.8 version. Okay, now this operator is introduced in Python 3.8 version. What is that operator? Colon and what? Equal. Right? So what is exactly now? Equal is there. Equal is called which operator? Assignment operator. What is equal is called assignment operator, and colon equal is called as which operator? Walrus. Getting or not? Okay, colon equal is called walrus. Okay, only equal is called which operator? Assignment operator. Okay, yes. Now faculty will have lot of problems, right? Teacher will have lot of problems. He cannot eat all the things. Last 2 days back, I ate one scoop of ice cream. Now suffering with cold. Okay, getting or not? So no sweets, no ice creams, nothing. Okay, if otherwise throat will go up, right? So you people are very lucky, right? Okay, because you can eat anything. Huh? Only one ice cream, one scoop or two scoops I think. जो ज़्यादा खा लिया हमने हाँ? So हो गया but that is what will happen right we have to take care right as a teacher right we have to take care otherwise students क्या सोचते हैं अरे ये लोग क्या कास रहा ये कर रहा वो कर रहा बोलता हाँ ऐसा no right So that is the operator colon, and what is that? Equal. Now you can eat anything, right? You can enjoy. So don't become a teacher, right? Become a software engineer. Okay? Yes. I was already working, but because of some reasons, I came to this field again. Okay? But partially, I'm working still. But anyway, is a both modes. I'm traveling like training as well as development, both. But 90% I'll be doing training only, but support I'll be giving also. Okay. But anyway, the problem with the teacher, I said, that is a problem. We cannot eat anything. We have to take care. Otherwise, this will happen. Okay, right? But you people can eat, drink anything, right? But I cannot do anything. Yes? Okay. So this operator is introduced in Python 3.8 version. This operator is introduced in Python which version? 3.8. And what is that expression is colon and equal is called as which operator? Walrus operator. Walrus operator. No, currently no yet. I'm not teaching data science. No. Maybe in future, maybe I don't know. But currently no data science, only Django. I want to tell you Django, right? Now today I'm starting Django batch at 6 p.m. in the evening. Okay, 6 p.m. in the evening. Those who are interested, they can attend. Okay, Django batch. But now you can join. Now you can join because initially in Django, I'll start with web technologies like HTML, CSS, JavaScript, Bootstrap, and jQuery. Once we complete this front end, then you'll be learning Django, that is backend. So to complete this HTML, CSS, JavaScript, Bootstrap, and jQuery, it may take some 20 classes. So by that time, 20 to 25 classes it takes. By that time, you will be knowing most of the things related with the Python. You can happily move into what? Django. So that you can become full stack what? Web developer. So those are interested to become a full stack web developer, they can attend. Okay. You can join now, no problem, because I said no, initially I'll be starting with HTML, CSS, JavaScript, jQuery, and Bootstrap. And these courses is free. Okay, actually your course is Django with that, because the person who come to the web development, he should have the knowledge of which one? HTML, CSS. Without that, you cannot develop web pages or web documents. You cannot develop web pages or web documents. So first, I'll teach that, and then we'll see the backend called Django and introduction to Flask also. Okay. So if you are interested, you can attend that. Okay. But anyway, yeah, evening 6 p.m. 6 p.m. And link, if you want to attend online, the link is already, I think, shared in the Telegram, right? Okay, you can just see that. I'll try to share it again. Okay. Yes. There is a walrus operator, that is colon, and one more is what? Equal. Right? I said, to get the job, you have to do some combinations. I'm not telling do only Django, right? To get the job easily, you have to do some combinations. Okay, learn Python with web development, Python with testing, Python with cloud, Python with DevOps, like this. You have to learn some combinations so that getting job will become very easy for you. Getting job easy for you. Not Flask, I don't take completely, but I'll take how to develop web application in Flask. Because I'll tell you how to develop it, because our concentration more is on Django, but not on the Flask. But I'll tell you how to develop a web application using Flask framework. So rest of the things you can explore it. Okay, right. This operator is introduced in Python 3.8 version. It is introduced in Python 3.8 version. Tomorrow, classes tomorrow, not today, right? Thursday. Tomorrow class will be starting, right? Not today, tomorrow. Tomorrow, not today. Tomorrow, right? Yes. So what is what is the assignment expression here is, what is assignment expression here is, assignment expression, yeah, it is a binary operator. It is a binary operator, and it required how many operands here? Two operands. It is a binary operator and it required how many operands? Two operands. It performed the operations using two operands. So what is this here? Operand 1 colon equal to operand 2. Okay, so there is operand 1 and colon and equal to what here? Operand 2. Two things are there. Operand 1 and colon and equal, and one more is what here? Operand 2. Okay. So, but what is the difference between normal assignment and assignment expression is, for example, this is called as a normal assignment, which is even for creating variables, right? I said a equal to 10. Now 10 is assigned to what here? A. And I'll say b equal to 20. Now 20 is assigned to which one? B. Now this is nothing but creating variables like a and b. So this is normal assignment operator. This is normal assignment operator. But assume that I'm trying to say, okay, I'm trying to write, suppose in one statement I want to assign value to A and B. Can I write A, some x equal to y equal to some 10? Can I write x equal to y equal to 10? If I'm writing x equal to y equal to 10, what is the value of x and y here? 10. This is multiple assignments or not? Yes. So 10 is assigned to y is assigned to which one? X. 10 is assigned to y and y is assigned to x. Now my requirement is, okay, there is one expression. There is one expression which contains 10 plus 20. Okay, 10 plus 20 and into, okay, 10 plus 20. Now there is one expression. What is that? 10 plus 20 multiply, okay, 5 minus 2, like this. Okay, now 10 plus 20 becomes what here? 30. And then 5 minus 2 is what? 3. Now 30 into 3 is what? 90. But I want the result of this expression should be assigned to one variable, and the result of this expression should be assigned to another variable. I want the result of this should be assigned to one variable, and the result of this expression to be assigned to what? Another variable. Can I write here? Can I write here some p equal to this? Can I write here p equal to this and q equal to this? And can is it multiply p and q and assign to z? No. This gives what here? A syntax error. This gives what here? Syntax error, because here we anyway. Okay, here we'll just open parenthesis, but even though you'll get which error, cannot assign to what here? Expression. Cannot assign to expression. Now what is the error? Cannot assign to expression. But if you want to assign to expression, I should use what? I should use what? Assignment. Assignment which operator? Expression operator. So if there is an expression, if there is a expression, within the expression, if you want to do the assignment, I have to go for which operator? Assignment expression operator or walrus operator. Assignment assignment expression operator, the same thing is called as which operator? Walrus operator. Now even if I'm writing like this, q equal to what I'm saying here, 5 minus 2. Q equal to 5 minus 2. I'm writing like this. So by putting inside what here? Parenthesis. Okay, now once I run this, it is given which one? Invalid syntax. Maybe you meant, what is that? Double equal or which one? Use. Instead of using assignment, is saying use which one? Walrus operate. Now, can you do the assignment within the expression directly using assignment operator? No. You have to use which operator? Assignment expression operator. So that is where you will try to use which operator? Walrus operate. Now all these are errors here. Okay, all these are which one here? Errors. To avoid this error, what I can do? I can simply say, I can write like this. In the place of equal, I'll try to say P equal, and in the place of this, I'll say what? Q equal. Now, is it? What happened there? Okay, now here I try to assignment operator, assignment expression operator. Now, is it given any error here? No. So what is the value of Z? 60, 90. And what is the value of P? 30. And what is the value of Q? 3. It means one large expression, what we are doing, you are trying to split. One big expression you are trying to split, right? Storing in multiple variables. Now I want the result of this should be in one variable, and the result of this should be in what? Another variable, and the result of this should be in one variable. That operation you can do it by using which operator here? Walrus operator. Walrus operator. Now this is how you are trying to use walrus operator. But I'll try to tell you more on this, like how you work with the walrus operators, and one category is there, which is called as assignment operators. And once we complete that, we'll go for another chapter called control structures, right? And after that, we'll start the collections or data structures, right? So tomorrow we'll continue this, and today we'll stop it here. And tomorrow we'll continue how to work with this operators. Thank you.